In this video, we're going to be evaluating complex fractions. And you might be wondering, what does complex fractions means? Well, basically, it's a fraction that has a fraction as a numerator or a fraction as a denominator or even both, a fraction as a numerator and denominator. Let me show you one example. My numerator in this case is a fraction, and my denominator is a whole number. So this is what you need to do. You always need to rewrite it as a division expression. What do I mean by this? That instead of you have it in a fraction form, you will rewrite it as a division expression. So it will look like this. -1/2 divided, you see, I'm using this division symbol, by 6 wholes. Now, you're very familiar with this. You know that under each whole number, there's an invisible 1 as a denominator. Remember that in order for you to divide fractions, you need to keep the first fraction the same, change the division sign for a multiplication, and flip the second fraction or use the reciprocal. So in this case, it will be -1/2. I will leave it at the same. Change my division sign for a multiplication and flip my second fraction or use the reciprocal in this case. Remember that when you're multiplying fractions, you only need to multiply numerator by numerator and denominator by denominator. You really don't care that they have different denominators because we're not adding or subtracting them. So 1 times 1 is 1, and 6 times 2 is 12. In this case, as my numerator is negative and the denominator is positive, or my first number is negative and the other one is positive, my final answer will be negative. So it is -1/12. All right, now let's take a look at this example. Again, do not freak out because you see so many fractions in the numerator, fractions in the denominator. Do not worry. You got this. Remember, the first thing that you need to do is to rewrite this complex fraction as a division expression. So it will be -1 2/3 times -3/5. Divided by 1/3 to the power of 2. If I were you, I'll put this in between brackets so I can see the numbers like more organized. According to PEMDAS or GEMDAS, as you might know it, I first need to do any grouping symbol. So in this case, I need to do this grouping symbol and then I will do my exponent or division. Let's see. So 3 times 1 is 3, plus 2 is 5. So -1 2/3 is actually -5/3, okay? Times -3/5. Let me close my bracket. Divided by 1/3 to the power of 2. Remember that in order for you to multiply fractions, you only need to multiply numerator by numerator and denominator by denominator. But hold on. As you can see, you can simplify first. Remember, this is optional. 5 divided by 5, 5 divided by 5. So this is actually 1, and here is 1. So I have, open my brackets, -1/3 times -3 out of 1. Let me close my bracket and bring down all the other numbers and symbols that I haven't used. So now I'm ready to do my multiplication. 1 times 3 is 3, and 3 times 1 is 3. So in this case, this is equals to 1. Remember that. I'm going to just leave it like that so you cannot get confused, okay? So now I have divided by 1/3 to the power of 2. In this case, you need to do exponent first. Let me do it here so I have a space. 1/3 times 1/3 which is 1 times 1 is 1, and 3 times 3 is 9. So it's actually 1, 9. 3 divided by 3, I have 3 out of 3 divided by 1/9. Remember that in order for you to divide these fractions, you need to keep the first fraction the same, change the division symbol for multiplication, and then you flip the second fraction, 9 and 1. In here, I can simplify first because 3 and 9, they share the same times table. 3 divided by 3 and divided by 3. So now this is going to be equals to 3, and this is going to be equals to 1. So I have 3 out of 1 times 3 out of 1. So my final answer will be 3 times 3, 9. 1 times 1 is 1. So my final answer is going to be positive 9. Okay? Now I would like you to pause the video and try to do this example by yourself. Remember, you need to rewrite this complex fraction as a division expression. All right, so let's write it down as a division expression. -2/9 divided by 2 and 2/5. Let's change this mixed number into an improper fraction. 2 times 5 is 10, plus 2 is 12. So it's 12 out of 5 because the denominator stays the same. Let me bring this other down. Remember that when you're dividing fractions, you need to keep, change, and flip. Keep the first fraction the same, -2/9. Change the division symbol for multiplication and flip or use the reciprocal, the second fraction, 5 out of 12. As you can see, you can simplify first. So 12 divided by 2 and 2 divided by 2. This step is optional. If you don't want to do it, hey, don't do it. It's totally fine. -1/9 times 5 out of 6. Now you're ready to multiply. Numerator by numerator, denominator by denominator. So 1 times 5 is 5. 9 times 6 is 54. As they have different signs, my final answer will be negative. So my answer is -5 out of 54. Let's try to solve this last exercise. So remember that the first step is that you need to rewrite your complex fraction as a division expression. So let's see. -10 out of 9 divided by, as there's an operation here, I suggest that you put this operation in between parentheses, okay? Parentheses, -1/6 plus 1. Close my parentheses. Whenever you see an operation either in the numerator or denominator, I suggest that you put them in between parentheses so you can remember that that's the first operation that you should do, okay? According to GEMDAS, you need to do parentheses, this grouping symbol. So remember that under each whole number, there is an invisible denominator of 1. In this case, as I need to add, I do care that they have different denominator. So I need to find the least common denominator. In this case, is 6. I'm going to multiply this one by 6 and multiply this one by 6. So now I have -10 out of 9 divided by -1/6 plus 6 out of 6. In this case, I am going to subtract this fraction because as they have different signs, remember the rules for adding and subtracting rational numbers, I need to subtract and use the sign of the greatest absolute value. So it will be 6 minus 1, which is equals to 5. Denominator stays the same. My answer will be positive because 6 out of 6 has the greatest absolute value. So let me bring down the other numbers and signs that I haven't used. Remember that when you're dividing fraction, you need to keep, change, and flip. I am going to keep the first fraction the same, change my division sign for a multiplication, and flip or use a reciprocal in the second fraction. So it will be 6/5. In this case, if you want, this is optional, you can simplify first. If not, just multiply 10 times 6 and 9 times 5, and then you simplify at the end. In this case, as I know that 10 and 5, they share the 5 times table, I'm going to divide this by 5. So I'll get a 2 here and a 1 here. As 6 and 9, they share the same times table, I will also divide this by 3, divide this by 3. So 6 divided by 3 is equals to 2, and 9 divided by 3 is equals to 3. So now I have 2 out of 3 times 2 out of 1. Now I'm ready to do my multiplication. Remember that 2/3, it was negative. Don't forget. So 2 times 2 is equals to 4. And 3 times 1 is equals to 3. As they have different signs, my final answer will be negative. But hold on. I cannot leave it as an improper fraction. I will continue the process here because, as you can see, I do not have more space. So I am going to convert my improper fraction into a mixed number. Denominator goes outside, numerator inside. 3 fits into 4 only one time because 3 times 1 is 3. 4 minus 3 is 1. This is going to be my whole number, and this is going to be my numerator. So my final answer, remember that is negative, okay? It is negative 1 and 1/3. That was it, guys. I hope you understood how to evaluate or how to solve complex fractions. See you next time.